Good evening. I'm Jessica Bironji, and I'm going to be taking you through the best descriptive statistics for public health professionals today. And our learning objectives today, by the end of this class, you should be able to understand the importance of descriptive statistics in public health, to identify the key descriptive statistics of mean, median, mode, range, variance, and standard deviation, and to be able to apply these statistics to interpret health data. So by the end of this class, you will have gotten to understand what descriptive statistics are. So in a world of statistical data, there are two classifications of data. We have descriptive and then inferential statistics. So what is descriptive statistics? The descriptive statistics are majorly techniques that involve describing and then summarizing the data, just to make it understandable and interpretable. But they do not allow us to draw any conclusion about the entire population from which we've taken the sample that we are studying. They are just giving us a brief summary or a description of our data. So what are the key features of descriptive statistics? These descriptive statistics are able to transform large volumes of data into understandable formats, say graphs, charts, tables that may be presented in summary measures. And they give a snapshot of the main features of a data set. For example, how the data varies, maybe for specific variables in the data, how they are varying over that sample that we have of the data. And maybe we can look at the averages. So they give you the key main features of the data, and you're able to understand what your data is containing at a snapshot. And these descriptive statistics focus mainly on describing that data without making any predictions or drawing any conclusions beyond the data. So what are the common tools used in descriptive statistics? So we have tables that usually give the summary measures within that data, and they are mainly meant to organize the data systematically. We have charts and graphs that help you visualize the patterns and trends in the data. May have pie charts, bar graphs, histograms, plots, box plots like scatter plots, among others. There are so many, depending on the nature of the variables that you want to describe and the nature of the data that you want to describe. So we also have numerical summaries that are usually presented in tables, and these may include the mean, the median, the mode, the range, and the standard deviation. So these are basically the most common tools that are used to describe data in public health. So let's look at this example. Benjamin. So looking at this example, we have an example of raw data that is usually commonly presented in Excel. I think some of us are familiar with Excel. So usually we have a data set like this that has respondents ID, Then we have different variables. We have age, gender in this case, and we have favorite car color. So we may want to see this a brief summary of our data from this data set that we have. We may want to have a visualization of what exactly our data entails. We can see that this bar graph is helping us summarize the gender, and the pie chart is helping us summarize the favorite car color. And you can see that 10% of the people have their favorite color as red, and 22% have their favorite color as black. So these descriptive statistics can be drawn using different statistical software. You can use Excel. There are so many other statistical software that you will, I think, study further in your computing and research methods. You can use Excel, you can use Stata Advanced, you can use R, you can use SPSS, Python, among others. So these statistical softwares simplify a little bit on how to come up with these descriptive measures and visualizations. So there are so many tools that you can use to draw these descriptives from your data. So descriptive statistics are divided into two portions. So we have the measures of central tendency, and we also have the measures of dispersion. So measures of central tendency are those values that represent a central point or value in a data set, or a specific variable in the data set that you have. So those measures provide a single value that summarizes the entire data set or a variable in the data set. And this allows public health professionals to understand the typical or average case in a population or in a sample. And the measures of dispersion, or sometimes they are called measures of variation or variability in the data, they usually describe the spread or distribution of the data around that central value. For example, the mean or the median. And they help us understand the degree of variability within a data set. And this helps us understand how consistent or scattered our data points are across or away from the mean or the median. So let's look at these measures of central tendency. We have the mean, the median, the mode, and then the quintile. So under measures of dispersion, we are going to look at them in detail in the next slides. We have the standard deviation, the variance, the range, and then the interquartile range. So let's look at each of them in a little bit of detail so we understand what each of them entails. So first, let's look at the mean, which is also commonly known as the arithmetic average. The mean gives us the sum of all data points divided by the total number of data points. And the sample mean is represented by X bar, and usually the population mean is represented by mu, the letter mu. And most of the time in statistics, we use the sample mean to draw inferences about the entire population. So in most cases, you will find that X bar is always used because we cannot we cannot study the entire population. We always have a sample, a representative sample of the entire population that helps us draw conclusions about the population. So in most cases, you will see X bar being used. So let's look at the formula. And this formula is showing you a summation of all the X's over the total number of data points, which is N, to give us the mu. So an example, so given this data set with these data points, 12 up to the various data points that we have, how are we going to get the mean from this data set that we have? So we shall sum all these data points to have 154. And the total number of data points we have is 11. So our mean will be 154 out of 11, and we shall have 14. As simple as that. So our mean is simply the sum of all the data points divided by the number of data points. So an example in maybe public health, we can look at the average blood pressure levels of patients in a clinic. When you have a data set that is looking at blood pressure, you may want to see what the average blood pressure of these patients is. So the most important aspect of the mean is that it takes care of all the values into account. It takes care of all the data points, and it is very useful for normally distributed data. The main limitation is that it can be misleading when data is skewed, especially when there are extreme outliers. That is very low and very high points. So if there are so many outliers in that data, you may need to work on the outliers so that you have a mean that is not misleading. Moving on to the median. The median is simply the middle number in the data set. When the data set is arranged in ascending order, that is from small to large. So if there are odd numbers of observations, then the median is the n+1 over the second ordered value. And then if there are even numbers, the mean is simply the average of the two middle numbers. So given this example, if you have a data set, points, you organize it in ascending order. So when you organize it in the ascending order, the middle number here is 12. So the median is simply the middle number in the data set. So a very common example is the median age. Usually age is presented using median because most of the time it is skewed. It is not most commonly it is not normally distributed. It is usually skewed in a data set. So median gives the appropriate statistic presentation. So the median, you may want to look at the median age of patients with blood pressure, or the median age of patients visiting a health facility. So the advantages of this median is that it is not affected by outliers. So it provides a better measure of central tendency for data that is skewed, as I've explained. Let's move ahead to the mode. The mode is the data point having the highest frequency in the data set. An example may be the most common type of disease symptom in a population, maybe during an outbreak. For example, during the most recent COVID-19 outbreak, the most common symptom was cough. So we would look at that as our median: cough, chest pain. So the mode, the most common data point in a data set is the mode. So there may be no mode or more than one mode in the data set. So this mode may not provide a clear measure of central tendency, because usually there may be none in the data set. So let's have an example. Given this data set still, our maximum occurring data point is 12 and our mode is 12. And when we look at this bar graph still, it is clearly showing us that when we have a count of our data points, the most popular, the green one, is giving us the mode statistic. Moving on to the quintiles. What is a quintile? It is any of these of the three values which divide the sorted data set into 4 equal parts, so that each part represents 1/4 of the sampled population. So the first quintile is usually known as the lower quintile, and it cuts off 25% of the data. It's commonly known as the 25th percentile. Then the second quintile is usually the median. Actually, it is the median, and it cuts the data set into a half, and it is the 50th percentile. Then the third quintile is the upper quartile, and it cuts off the highest 25% of the data and the lowest 75%, and it is usually called the 75th percentile. So the difference between the upper and the lower quartile is called the interquartile range. I think Juma put up the hand by mistake, so we can continue. So these measures of central tendency help provide a simple, concise summary of the large data sets, making it easier to understand the key patterns in the data. They summarize the health data really like so quickly. For example, if you have a big data set of hospital admissions, or the number of admissions in a facility, and you want to know the average number of these admissions per day, so it can help you really summarize those numbers and have a quick snapshot of healthcare demand. You would want to easily know what you really have to do, like from that big much data set or that record that you've taken from in your health facility, and it will help you make decisions of what is being demanded, the average number of hospital beds. Like, it really helps you get that quick snapshot. Then secondly, they help inform public policy and interventions. They make decision making like so really fast. For example, if we look at the average life expectancy, the median income, median age of teen pregnancy, average vaccination rate, this may help like evaluate the success of different interventions, and also help like policy decisions and resource allocations to different groups of patients or vulnerable populations. Can help us easily identify vulnerable groups that need targeted interventions. And these descriptives also help us describe population characteristics. They help us give us a typical health profile of different populations. For example, what is the average age of mothers that are giving birth at Kawempe Health Facility or in a certain health facility in Juba? What is their average body mass index? What is their average body weight? What is the average weight of the babies that are born at this health facility? What needs to be done first basing on this information? So it helps us give a measure of population characteristics and many more that you can think about. So looking at also comparing subgroups within populations, they can help us easily compare different subgroups within populations. For example, comparing the median age, this is median age of onset of diabetes in urban areas versus rural areas. Can look at the education level and how it varies in urban areas and rural areas. Teenage pregnancy, how it varies within different regions in South Sudan. Immunization uptake, how it varies within different regions, within different age groups, among others. And it can also help us to communicate findings easily, clearly, with simplicity to different stakeholders, because most of the policymakers do not understand statistics. But if these descriptives are giving us, for example, reporting the average infection rate during a disease outbreak and communicate the urgency of a public health response, they may not be able to understand the data real quick, but the visuals will give them a clear understanding of where they really have to take urgent response. So public health professionals also use these measures to track progress or decline in health metrics over time. These measures act as a benchmark for monitoring health programs since they track changes over time. For example, monitoring changes in the average CD4 count of patients receiving at a health facility, it helps monitor disease progress. So public health professionals can implement any preventive or interventions easily. So let's look at the measures of dispersion. So we have range, which is the difference between the highest and the lowest values in a data set, or for a given variable in a data set. So it is simply the formula simply gives you the maximum value minus the minimum value. And given this example, when we look at the range of systolic blood pressure levels among patients at a clinic, it is simply the difference between the highest and the lowest. as clearly shown in the figure. So the range is very simple to calculate, and it gives us a very quick sense of the data spread, how the data is spread, but it is very sensitive to outliers, and it provides no information on how these data points are distributed between the extremes. So that is why we move on to the standard deviation, which gives us the average distance of each individual observation or data point from the mean. So for our population, the standard deviation is represented as sigma, and for a sample, it is usually just represented as S. So that is the basic formula for standard deviation, where S stands for the standard deviation of the sample, Sx, and xi is the value of each variable or data point in the data set. X bar represents the sample mean. N is the total sample size, and summation stands, and this stands for summation, which is the sum of xi to x bar for all the values of x. So we can see clearly in this figure that the standard deviation is represented by the distance between each of the data points from the mean. So it is very easy to interpret, and it is widely used. It really indicates the typical distance of these data points from the mean, and it is still very sensitive to outliers. So if the data point is really very far from the mean, that means the standard deviation will be large. And if the data point is really close, we see the standard deviation is small. So what is the variance? The variance is the square of the standard deviation. So it is basically getting the standard deviation and then squaring it. It uses all the data points, and it provides a comprehensive measure of spread. And since it is based on squared differences, it is not of the same unit as the original data. So this figure is representing different variances, and we see that the sharper the graph, the lower the variability. So the wider the spread, the higher the variability, the higher the variance, and the sharper the spread, the lower the variability. So the red one has low variability, the blue one median variability, and then the green has a higher variability. So let's look at the interquartile range, which is simply the difference between the first quartile, as we described above, and the third quartile. So this measures the spread of the middle, 50% of the data effectively, eliminating the influence of outliers. Most of the time, when you report median, you have to also report the interquartile range. For example, when you're reporting the median age, we expect to also see the interquartile range reported as well. So the only limitation of the interquartile range is that it only focuses on the middle range. It does not use all the data points, although it offers a better summary of data spread in skewed distributions. So why are these measures of dispersion important in public health? They give an insight into data variability. They help us understand the consistency of variability in our data sets. They also give a measure of risk or an uncertainty in our measurements or in our data sets, which is very important in decision making. And they also help us compare variability between different populations or subgroups. For example, regions, age groups, education levels, different groups of the populations. So they help us compare variability between these populations. And I think that marks the end of today's lecture. I've indicated some articles that you can read further to help you understand how these measures can be computed. Actually, at this level, we do not compute them manually. There are very many softwares, like I said before, that can help us compute these measures in a click. Thank you very much.